Well, we're going to talk about square roots. Square roots get really confusing because a lot of times people are learning square roots, they really want to focus on steps. And often people are instructed on how to do square roots by prime factorization, and then the methods are disconnected from the actual math. And the thing is, math is not steps. Math is the thinking that guides and determines steps. So I'd like to have this in mind when I teach you about square roots right here. So first of all, the square root of 50, that's how you say it, but what you need to think is this is asking a question. And what it's asking is, it's asking what number times itself, what number squared is 50. That's what this is asking right here. So when you see a square root, you're asking what times itself is equal to the radicand. The radicand is the number that's inside the square root. So without showing you how to get the answer, let me explain why this is the answer. The answer is 5 times the square root of 2. This number times itself is 50. Okay? So let me show you that right here. 5 times the square root of 2 squared. That would be 5 times 5 is 25. The square root of 2 times the square root of 2 is just plain old 2. Like if you wanted to do it like this, you could, and that would be the square root of 4. The number times itself that is 4 is 2. So anyway, that's where you get 50. 25 times 2 is 50. This number times itself is 50, and that's what this is asking. Square root. So another place square root comes from is actually, if you look at the word square, right? And root is where something begins. So if this was a square, if the area was 50, the square root's asking, how long is the side? That's what it's asking. If the area is 50, how long is the side? So the side would be 5 root 2, because 5 root 2 times itself, you know how area is the side squared? 5 root 2 times itself does equal 50. Okay. So let this understanding about what square roots ask and where they come from guide how you manipulate them. Let's talk about the square root of 48. Okay, so the square root of 48, that's how you pronounce it. This says the square root of 48, but what it's really asking is what number squared is equal to 48. So the thing is, the question itself is asking for a number squared. So when you're factoring the radicand, 48, what you're looking for is a perfect square. So to simplify a square root, the first thing you do is factor, but while you factor, you got to look for the biggest perfect square. Don't look for prime numbers, look for the biggest perfect square. Now 48 is a tricky one. We have a couple options right here. The factors of 48, you could do 2 times 24, you could do 4 times 12, 3 times 16, or 6 times 8. So we got these 3 ways we could start, or these 4 ways we could start factoring the square root of 48. The thing is, this is asking a question. Let's make our work answer that question. We're looking for numbers squared. 16 is the biggest number squared I've got out of all of these. So I'm going to use this pair of factors to simplify the square root of 48. So the square root of 48 is the square root of 16 times the square root of 3. The number times itself that's 16 is what this is asking. Well, the answer to that question is 4. The number times itself that is 3 is just the square root of 3. This is irrational. You can't actually write the number. You can only write an estimate of it. So we just leave it written this way. So 4 times the square root of 3 is equal to the square root of 48. And the reason why is if you had a square, right, and the sides were 4 times the square root of 3 feet or whatever, then the area would be 48. If you squared this, you get 48. That's what it asks. Alright. Now, let's do a couple of examples right here. The square root of 75. The way we handle the square root of 75 is we factor it and we look for the biggest perfect squares. I happen to know that 25 goes into 75 3 times. 3/4 is 75 cents. The square root of 25 is 5. Sorry, my pen's dying there. So the square root of 25 is 5. So 5 times the square root of 3 is equal to the square root of 75. They're the same exact number. This number times itself equals 75. This is asking what number times itself equals 75. Now, 24 is a little tricky. A lot of times people want to say, well, what about 3 times 8? And they start off with that. It's not the smartest way, because when you're factoring you need to look for the biggest perfect square, but sometimes you just don't recognize it. So you have to look at those other factors. You see, 8 is 4 times 2, right? So this would really be like 3 times the square root of 3 times the square root of 4 times the square root of 2. Now, the square root of 4 is just 2. There's not, like people often use the phrase, well, we take out the 2. You don't take anything out. You're writing what this is equal to. The square root of 4 is 2 because 2 squared is 4. Now the square root of 3, can't do anything with it. It's irrational. Same with the square root of 2. It's irrational. This is the right answer, but it's kind of ugly. We usually want to put the rational numbers in the front and then combine those irrationals back together, and there we go. So the square root of 24 is equal to 2 times the square root of 6. And again, the reason why is if you took 2 times the square root of 6 and you squared it, you would get 4 times 6, which is 24. This asks what number times itself is 24. Now, these two really get students confused, but the giveaway is there's a factor of 100 right here. This is 100 times 5. This is the square root of 100 times the square root of 5. Now the square root of 100 is 10, and the square root of 5, it's irrational, so you're done. This one might be a little trickier though. And the reason it would be a little trickier is you might not recognize that the square root of 8 has a factor that's a perfect square. This is 4 times 2, right? So I'm going to write that instead. So this would be 10. The square root of 4 is 2, and we still have a square root of 2 left. So this would be 20 times the square root of 2. All right? Last example. What if we had something like this? So this is multiplication, and even though you don't see a dot in between the 3 and the square root of 5, they're multiplying also. Same with this 2 and this 6. There's no dot in between, but they're being multiplied. And with multiplication, the order doesn't matter. So, for example, 7 times 4 is the same as 4 times 7. You can change the order around. So the smart thing to do would be to put the rational numbers together and put the irrational numbers together like this. The whole time checking to see if you've got anything you could simplify. 6 is 2 times 3, so you can't simplify that square root. And you could probably do this in your head. You could just think about this is 6 and that is 30. That's it. Anyway, I hope this video helped. Have a good day.